Folks, I am going to show you how to do the bond enthalpy calculation using the example in your study guide, which I believe is on page 1. So we're looking to find the delta H for this reaction. And it's essentially we are burning propane, complete combustion of propane. So you have to know, in order to do this, what the structure is when we have all of these different substances. I'm going to draw out the propane structure here. It is something that you guys will learn later. I also, for what it's worth, have the propene and propane structures on the board for you in case you want to do the next problem in the study guide. And then you can check your answers on Canvas in the answer key. So let's take a look at this. We've got C3H8. This is going to be 3 carbons bonded to each other, and then 8 hydrogens, basically filling up all the spots on the carbons. So that is our propane. And then we've got 5, and we've just got one of those, because remember there's an invisible one in front of the chemical formula. Then we've got 5 O2s. Each one of those is going to be a double bond. I'm not drawing the lone pairs in here because they don't particularly matter for our purposes. This is not something you have to do each time, but if you don't know the structures off the top of your head, then it's important to kind of draw them out so that you know what type of bonds you're looking at and how many of them there are going to be in this reaction. And then we've got 3 CO2s, so that also is going to have some double bonds, carbon-oxygen double bonds in this case. We've got 3 of them. And then our 4 H2Os. Okay, so that is what we are looking at here. So now we need to find the enthalpies of each of the bonds in the compounds and multiply them by how many bonds we have. So for our propane, we've got carbon-carbon bonds. We've got 2 carbon-carbon bonds, single bonds. And we've got 1, 2, 3, 4, 5, 6, 7, 8 carbon-hydrogen bonds, single bonds. Of course, they're single bonds because it's hydrogen. Okay? For our O2, we have 5 oxygen-oxygen double bonds. For our CO2, we have 2 carbon-oxygen double bonds per molecule, and we have 3 molecules. So we're going to make that 6 times the carbon-oxygen double bond. And then for water, we have hydrogen-oxygen bonds, and 2 for each molecule, so that means we're going to multiply that by 8. Okay. So each one we can look up in our data booklet. So we can see that our carbon-carbon bond is here. That's going to be 346 kilojoules per mole. So that's going to be 346. Our carbon-hydrogen bond is going to be here. That's going to be our 414. Our oxygen-oxygen double bond. Remember, the multiple bonds are below. So here is our oxygen-oxygen double bond, 498. Okay. And our carbon-oxygen double bond, also going to be down here. Here it is at 804. Not surprising that the double bonds tend to be a little bit higher. It makes sense that it would take more energy to break those. And then finally, our oxygen-hydrogen bond here at 463. Okay. So when we set up our calculation, remember that our formula here is that we're going to take the sum of the enthalpies of the bonds that are breaking, and we're pretending that we're breaking all of the bonds in our reactants to make individual atoms. And then we are forming all of the bonds in our products, and we're going to subtract those. So bonds broken minus bonds formed. So total bonds for the reactants minus the total bonds for the products. So let's set that up. So over here on our reactant side, so our delta H is going to be equal to the sum of, actually, I'm not going to write that out again. So we're going to have 2 times 346 plus 8 times 414 plus 5 times 498. Okay. And that whole thing is going to be then minus the sum of all the bonds on the product side. So here we're going to have 6 times 804 plus 8 times 463. Okay. So you can do this calculation however you want. If you want to break it down into pieces, that's fine. If you want to use parentheses in your calculator to try to do it all at once, that's fine. Whatever works for you. I'll go ahead and break it down just to make sure that we're all on the same page. So 2 times 346 is going to be 692. Oops. 692 plus 8 times 414 is 3,312, and 498 times 5 is 2490. So we're going to add all those together, and that's going to be the sum of the bonds from our reactants, and we're going to subtract the sum of the products. So 6 times 804, 48, 24, and 8 times 463 is 3704. Okay. So if I add up the reactant side, get 692 plus 3312 plus 2490, I end up with 6494 minus 4824 plus 3704. That gives me 8528. So that means my delta H for the reaction is going to be 6494 minus 8528, which gives me a total of negative 2034. And this is going to be kilojoules per mole, because that's the units that we saw on the table for our bond enthalpies. So that is how, once you have your structures, that is how you're going to do the calculation. Really, the structures is the hardest part, and then just making sure that the calculation is set up properly. So you should be able to now at least attempt all of the problems in your bond enthalpies packet that you got yesterday. And you can also, if you would like to, you can check yourself by doing the questions in the study guide on page 2, I believe, and then check your answers on the answer key in Canvas. Good luck. I will see you tomorrow.